Okay, it's the good, the dead, and the ugly code, because it's also a little about beautiful code or not beautiful code. But mainly as you're here, I hope you have at least some familiarity with JavaScript. I'm going to show some code samples today. And probably bundling is something that has become very important since JavaScript has become a language to write whole applications in. Why? Because browsers have very hard limitations on how much data they can fetch at one time, so the natural idea is put everything together in one bundle. So the usual choice used today is Webpack, of course. I hope most people have at least heard of Webpack. I'll talk a little about Webpack today as well, but I'm mainly going to talk, of course, about Rollup. So why Rollup? So this is an article from the year 2016 by someone called Nolan Lawson. He's working on the Microsoft Edge team. This was the first time I heard about Rollup myself, and in this article he compared different bundlers. So he artificially generated a module structure with thousands of modules, then put those into various bundlers and then ran them in the browser and compared how much time was actually wasted parsing the code and processing the code until anything happened, and how much time is wasted switching between the modules. And the result was rather staggering, that there's really a high cost to be paid if you use small modules, which is kind of sad because small modules is a good programming pattern, but it's bad for the code itself. And there was one exception, so he ran through the most popular solutions at that time. That was, of course, Webpack, Browserify, and others. And Rollup performed noticeably better than the rest, with one exception, which would be Google Closure Compiler, but it's not as widely distributed, but it's a cool product nevertheless. So the question I'm going to talk about today is, why is Rollup so much better? And so what is Rollup? As I already said, it's a bundler and JavaScript optimizer. It was created by someone called Rich Harris in 2015. Rich Harris is actually not a programmer by profession. He's actually a journalist who happens to have created a huge number of great open source projects. So he not only created this bundler, which is probably his most prominent software, he also created an alternative to Babel, for those who know it, which is much faster and a little dirtier maybe. And he created his own UI framework called Svelte, if you want to check something out, which is also really cool. It's all pre-compiled and who knows what. But okay, I'm losing track here a little. So as already said, this software is actually used by many JavaScript projects you might actually be using. So React, Vue, Ember, Angular, all the huge frameworks actually use it. So what I also want to talk about is, does it make sense for a front-end developer to actually use Rollup? The answer is maybe. Yeah, but myself, as already said by Andreas here, I have been a contributor to Rollup since summer last year. So it started a little earlier. I promised to do a presentation at the Munich Node user group like early last year about Rollup, because I always wanted to do a presentation, and I thought, oh, this is cool, I heard about this. Then when I started actually working with the software, I discovered, well, the features do not seem to work as advertised. So then I started creating an ESLint plugin to highlight situations where the bundler wouldn't optimize as I was expecting. Then this all turned into me making a pull request to Rollup and then making a larger pull request. And then 2 months later, Rich Harris contacted me and said, oh, well, it looks cool what you do. Here you have full access to the Git repository. Do as you please. And I said, okay. First of all, I did not do as I please for 2 months, but then my pull request lay there for 2 months. And I thought, okay, maybe the idea is I start merging it myself and releasing it. The result was that basically for the next day, of course, I released it on a Monday and went to work. And the whole day I had reports of, oh no, it's no longer working, it's crashing, my code base, it's hanging. And I said, oh God. Okay, so this was a few stressful days. We improved testing and the release process since then and started doing smaller pull requests that are a little easier to manage. But basically, since November, I'm the person doing releases there. So if you think this is really cool, actually it's really easy, as I turn out, because there are many open source projects and very few people contributing. And if you say, oh, I want to take responsibility, there will be lots of people who say, okay, here, got it. Okay, but actually I want to talk about rollup and how it works. And to understand a little better, I want to give you a very, very short history of bundling itself. So to understand bundling, you have to know JavaScript for the most time of existence didn't have a module system to speak of. So people invented solutions, and the result is that now you have like at least 6 different module formats you could use. The first not actually being a module format, but the solution that people come up with if they don't have anything to modularize their code. I'm mainly going to talk about 2. So this is the common JS format. This is used by Node.js on the server. This been around, I think, 2012 or 2009 actually. And the other format is finally in 2015 the ECMAScript modules format, which is the official language feature to make modules. And of course, if you have modularity, as I told you, you have performance problems to get all your code to the browser. And so, of course, many different solutions popped up. So I'm only going to talk about 3 of them shortly. There are many more, actually. It's JavaScript, so if you have a problem, you find 20 solutions. That's how the community works. And all are the best and the blazing fast solution, whatever. So there's Browserify, which is really important. The main goal of Browserify was actually not bundling. The main goal was enabling Node.js server developers to use their code in the browser as it is. So what it did, it emulated the Node runtime environment. It also includes polyfills, so replacements for the built-in Node libraries and so on. And so how does it work? So in theory, it takes all your modules, puts them in a huge map. And each time one of the modules imports another module, it looks up in the map, okay, do I know this module? Did I already run this module? If not, I run the module and then I return the exports. So this is how such an emulated runtime works. And of course, the runtime needs to ship to the browser as well. So you get all your code plus glue code around it that connects the various modules. Webpack is basically the de facto standard today. It builds on the very same ideas as Browserify, and it supports very many more formats. So of course, it supports the ECMAScript format as well, besides CommonJS. AMD is something known by a project called Require.js, which was somewhat popular at least some years ago. It also has, of course, a custom runtime loader, and there's Rollup. And Rollup is built internally exclusively around the ECMAScript module format. And the main difference is there is no runtime loader. So basically, all the code you ship to the browser is code you wrote yourself. It's actually less code than you wrote yourself, as we'll see in a moment. And it's, in a way, more efficient code. So the question, why is that? And this is related to how the ECMAScript module format works. So if you don't know about JavaScript, you might learn a few interesting things. If you know about JavaScript, you still might learn a few interesting things. So I've got 2 examples here. This is mainly equivalent code. The first is a common JS module. So first we define a constant, then we import another constant from another file called other.js, and then we log both. So this is the common JS way. The ECMAScript way looks somewhat similar. Instead of defining a constant and requiring it, we are importing the constant. But basically, everything else is the same thing. So, but there's a difference in how those 2 pieces of code are executed. And the difference is the common JS format starts top to bottom. So first, it executes the declaration of X. Then it wants to declare Y. It sees, OK, I have to run other.js to declare Y. So I do that, assign this to Y, and then I log this. So if you look at the execution order, the execution of other.js is interleaved with the execution of main.js. So you have a very dynamic execution order, and it is even more, it can be even more dynamic than you see here, because I could write an if statement around the require and say if it's 10 past midnight, then require this, otherwise do not require it. And I have no chance initially when I look at the files to see, okay, is this executed, when is this executed? The ECMAScript format is different because it's mainly working in a two-step process. So in the first pass, the runtime only looks for the import statements. And it sees, okay, there's an import of other.js that I will need to run this file, so other.js is executed first. Then the import happens, and then we start with the first line over here. So basically, this allows us to, just by looking at the file, know in which order everything will be executed. So if I have a whole code base of modules that are importing each other, with this format, I can just statically look at the files and say, okay, I need to execute them in A, F, B, C, in this order. And this is exactly the order, and it doesn't depend on any other circumstances. So if I want to write a bundler, I could just do the following. I could just take this order that I just determined and concatenate all the files one after the other and just execute them in this order. The only thing I have to solve is what is an import. I'll get to that in a second. Because there's a nice ECMAScript feature about imports as well. So again, I've got two code samples. This is a little more code, so I'll explain it again. We're starting with the main.js file at the top. Again, we're requiring a y from the other file. Then after 2 seconds, this is what the line here means, after two seconds we print its value. Okay. And in other.js, we first export the number 1, and then after 1 second we switch it to 2. So the question is, what will be logged in the end? Will it be 1 or will it be 2? And of course, it's a different answer for both module systems. So in the first case, here, this assignment in the top, this is an assignment of a value at the time when it is executed. And when the first line is executed, the export is 1. It's only 2 seconds later that it changes, but there's no connection with the y and module.exports. So the output will be 1. If I wanted to output the 2, instead of writing y here, I would need to write require other.js again. Then I would get the y. But basically, it's each time I do require, I copy kind of the variable to one of my local variables. And it's different variables. Now, in the ECMAScript case, this is very different. Because this import is not importing a value, it's importing a so-called binding. This means this is the variable y from the other file. It may have another name. I have the option to rename it while I import it, but basically it is the same variable. And when I change the value after 1 second, the value in the other file will change as well, and the output will be 2. Now this may seem weird a little at first. Why do I want this connection? But the idea is so that you can do exactly what rollup is doing. If I want to resolve the imports, I can just use the same variable. And so this is the second ingredient we have. And putting this together, this is something called scope hoisting. This is a term actually invented by rollup, I guess. I'm not so sure. And since this presentation is running in a browser, that can of course just run rollup. Okay, here's my mouse. So when I press, so this is just the example from before. So it's the import. After 2 seconds, I log it. After 1 second, the value changes. And yeah, this is what rollup will produce. So of course, we're starting with other.js. As I told you, the import says I need to process the other file first. Those are the 2 lines from other.js. The export has just been shortened to become a declaration. Then here's the one timeout statement. The import completely vanishes, it's no longer necessary, and then I just have the set timeout from the other file. And so you mean, so the thing is, if you have 100 files, in the end it will still be one huge module with everything together. And maybe there's one question that you might ask, okay, so what happens like if I have a variable of the same name, like say I have a constant x with the value 1 here, and I don't know, somewhere over here, a constant x with a value 2. So what will happen? The answer is nothing will happen. Why? Is it broken? No, actually it's not broken. This is by design. Because I'm not using the constant x. So it doesn't have an observable effect that I define the constant here. So let's just add some side effect here. So we're logging x over here, and we're logging x down there. And magically the x appears, and you see it has started adding this $1 here to be able to tell them apart. Okay, so this is the main idea of rollup. But there's another idea, and this is actually not the thing I wanted to talk about mainly today. The other thing I wanted to talk about is, well, now that we know all the variables and we have this huge module scope, doesn't give us more opportunity for dead code elimination. So one thing about JavaScript is, of course, if you want to ship it to the browser quickly, then a single file is better than many small files. But of course, a smaller file is even better than a larger file. And if you use a utility library with like 100 functions and you use 5 of them, why should you include the other 95 functions? And this idea was also part of rollup from the very beginning, and it's called tree shaking. So why tree shaking? Sounds kind of silly. Sounds silly enough so that Rich Harris wrote a very nice article about what tree shaking is and why we have a different name for tree shaking, not just call it dead code elimination. There's even a Wikipedia entry on tree shaking. This entry does nicely match the article by Rich Harris. I'm not sure this is a coincidence, but I didn't check who wrote the Wikipedia article. The idea of tree shaking, the first thing, it has nothing to do with ECMAScript modules. Many people think, who read about these matters, think this has something to do with the module system. The tree we are shaking is actually the syntax tree. And I'll show you in a second what this means. And to give you an idea, let's look at what a traditional dead code elimination algorithm would do. So I have a small module with lots of dead code, obviously. So I have an unused function here, 2 other unused functions here, which are calling each other and importing something from here. And then I have an if statement that is always resolved to the first branch. Okay, so what would the algorithm do? It would discover 2 things. First, it would see, okay, the unused function is unused. So, okay, I can eliminate it. I can count usages. I see, okay, there's no other usage of unused, so this declaration is not necessary. And it will see, okay, the else branch of the if statement is not necessary, so I can remove this as well. Then it will probably do a second pass, again counting reference and see, oh, get value is also no longer used, so I can remove this as well. And yeah, that's it. And what's a little sad is those 2 functions in the middle. And if you know a little about, well, this is similar to another problem, I'd say. This has been solved in browsers for many years, which is called garbage collection. And so in garbage collection, you have the problem, okay, if you have like 2 objects that are linked with each other, it's very hard to remove those objects by reference counting because one object has a reference to the other and the other way around. So what do browsers do? They start with a global object and then going down everything that is visible from the global object. And see there's functions, everything that's visible in the function scope, and so on and so on. They're marking everything they find and everything else is removed. This is called the mark and sweep algorithm. And the idea of tree shaking is actually we do mark and sweep elimination with our code. So I have the same code as before, and now we're doing it the tree shaking way. The tree shaking way would say, okay, first we are marking the things we definitely need. In this case, there's only one thing we definitely need. This is the export, because this is the public API of the module, so I need to include it. Then I do a parse and see what else do I need now. And then I see, okay, x is assigned a value over here, so I need to include this as well. We'll also see that the other branch is not entered, so the other assignment to x will not be included, and we're done. And you see there, we never had to touch those two functions over here. We didn't have to invent any crazy logic. I mean, this can get really ugly if this is not a direct circularity, but over many stations, over many files. And yeah, this is how I came into this project. And well, it didn't work this way when I came. Or it worked, but it didn't work in many situations, and it produced some false results. And to give you an idea how we actually do this, I want to get a little deeper into how rollup works. So this is the deepest we're going to go today. I hope I can take you with me a little more. So how does rollup create a bundle? So basically I've got 4 phases here. This is just my rough splitting it up. The first phase is called the parse phase. And of course, we are starting with a file. We are creating an abstract syntax tree for the file. And then we need to understand the syntax tree in a way. So we're creating a hierarchy of scopes. So if you have a function opens a new scope. So variables defined in this function do not leak outside the function, and so on and so on. And then we collect all declarations and put them into the scopes so that we know, okay, this x is visible from here and from there. And when this is done, we can take all remaining identifiers and we know exactly which variable is which declaration. So this is something that needs to be done, of course. And of course, when we do this, we discover other files. There's an import to a new file, so we repeat it with a new file. In the end, we have a lot of separate syntax trees plus additional information. So, and then the linking phase is the interesting one. Now we are linking the imports and the exports. This is just some references put together. And the tree shaking is like the third phase. So as I told you, we're starting with the external exports. And then we take several passes through all files and then incrementally include new things. We also include things that have side effects, of course. Side effects are usually global functions that are called. Console log is a global function, so that's why it is a side effect. We never wrote that console log is a side effect. It's just because we never wrote it, it's not a side effect. And in the last step, the rendering is basically what I told you in the beginning. So we concatenate the files, we rename the variables, we remove what is not needed, and we have our bundle. So how is this realized internally? The idea is very simple. The nodes of the abstract syntax tree are extended. So the abstract syntax tree in JavaScript is usually very standardized. That's very nice. So other languages have many different implementations of this. And we take the nodes, we have a parser, we didn't write it ourselves, it's called acon, and each node now has a function, has effects. And this function tells us, does this node have an effect when I execute it? It's as simple as that. This is not my idea, this is the idea that was present last summer. What was a little sad is that it was, for some reason, only removing top-level statements because, I don't know, the original creator thought this is the most important one. It probably is the most important. But it, of course, skips many improvements that are possible. And the other thing is, when you have a function that calls other things, it would be nice to identify a function that doesn't have a side effect so that you can remove more code. And this was already present in the original code 2017, but basically it replicated the whole algorithm in a completely different way, which produced lots of bugs. So the question is, if you want to go through function calls, how can you implement this in a clean way that is like extensible? And to give you an idea, I show you how it works today. So again, I have a file here. they are starting again with the export. And then we're going from top to bottom. So first start with the declaration. We ask the declaration, do you have an effect? The answer is, of course, false, because nothing's happening with them, until we get down here to the call of this is assign values, which is the function over here. Now, how do we determine if assign values has an effect? What's happening is this function talks to its declaration now. The function asks the declaration, do you have an effect when I call you? And the declaration says, let me look. So I'm looking at my first statement. So that, again, asks the assignment over here, do you have an effect? And the assignment asks this declaration, do you have an effect when I assign a value to you? And since this is an export and part of the public API, the value says yes. And then we can resolve everything. And we know, okay, this has a side effect, so we need to include assign values. And so that is all valid. We also need, of course, include the declaration, but we do not include the content yet of this function. And we also set a flag. We need to do this a second time. So we start again from the top. No effect here, no effect here. Now, since this is included now, we need to step into this function as well. We already know the answer to this. Yes, this needs to be included as well. No effect here. Then, again, we need to step into this function. And there's also no effect. And we're done. So as you can see, the idea is now that there's a lot of communication between the nodes, and the logic for each node is now only found to be at that node. There's, so I don't know, a call expression, that's what this down here is called in the syntax tree. So something with opening and closing round brackets. Doesn't need to know how a function works. It just needs to know that it can ask the function, can I call you, and if I do so, does it have a side effect? And if this isn't a function, but this is a number, then the number will always say its default, but it is, yes, I have a side effect because I don't know what it means if you call me. And this makes the code really, really nice to work with. And this was also, and this is also the basis for many new things we are now implemented. Just going to show you an example, 3 of them. The first I call value tracking. So this is tracking what value a variable has. This is somewhat limited because we're not tracking reassignments. So when we reassign a variable, we just say the value is unknown because I tried a different approach first, the performance was basically unmanageable. But maybe we'll get there at some point to have it dynamically. Object shape tracking, really nice, and return value tracking. So I'll show another bit of code here. And just show the result. The result of this code is this will be what's left. That's the only reason I put the console log in so that you can see anything happens. So there are 3 things happening in this piece of code here. The first is about value tracking. So I have an array. Now, then when I call map on the array, rollup knows this is an array, and arrays have a map method. And map methods do not have a side effect unless there's a side effect in this function here. So I could just go ahead and add a side effect here, and then it will be included. So just remove the side effect again. It also knows that there's probably no maps method. So it would be really a pity if the error thrown by your runtime environment would be swallowed by this code. Okay, there are few errors we actually swallow, but okay, it's very few errors. But most errors will be nicely preserved so that it's really equivalent. The second example is here I define an object and it has a nested field and there is a method. And I call this method, and the method doesn't have a side effect, and again, the code is removed. If I went ahead and said, okay, this method logs something, then again, the object will be included. By the way, something nice about is you see this code looks very similar. So we're taking actually great care to preserve the formatting. So if for some reason, say you want to have an annotation comment, this is something that's really becoming popular, like saying this is pure or something, then this comment will be placed exactly where you put it. So if you have a very nice code style, then the output will also have very nice code style. And if you have a very weird code style, the output will also have a very weird code style. Because you probably like it that way. The last example is a function returning a function, which also doesn't have a side effect that I would call with double brackets. This even combines nicely with the previous feature. So if instead of returning a function, say I return an object containing a function like this, then I could also put this here and still tree shaking. And if I add a side effect, then it will be re-included. Okay, so this is what we have today. Even did a release early this week where we added another feature which is basically tracking values of conditions in if statements and logical expressions. So you can, like, if you have a constant x equals true somewhere, and then you have if x somewhere else, this will be correctly removed, or the branch that is not executed will be correctly removed, even if there are some nice transformations. If x or 7 equals 5, whatever, this will work as well. So what are we working on for the future? Object properties. This is an important topic. I had this talk 2 weeks ago, and there was a question, why would I want to remove properties of objects? Well, the issue is actually the CommonJS module format. CommonJS modules, I just gave you a glimpse very early where I exported a single value, but usually CommonJS modules export objects with various values attached. So what you want to do is to remove parts of the code, you need to tear apart this object. So this is one thing we're working on, to be able to remove object. This needs some careful de-optimizations because, of course, if you pass this object somewhere where you have no longer control over it, and it needs to be in its original shape, but if it's all in your control, then you can do as you please, as long as you can be 100% certain nothing bad happens. Yes, and inlining. So what does this mean? If I use a variable only once, then why do I need to have it as a variable? It's nice in my code to have a variable to give it a name, but actually for optimization purposes, it would be much nicer to have it where I use it. This could be even extended to functions. So this is another thing we're working on. And this can also, if the variable is like an object and I only use one property, then I could get rid of the remains of the object and of the property access. Okay, so this is the deepest we're going to get today, so let's dig a little up here. The question that's maybe more interesting to you is, should you use rollup if you're a JavaScript programmer, or would it be interesting to use rollup like in a project you're responsible for? And the answer is, depends. So there's another nice Rich Harris article about this. Basically, he says, if you write a library, you probably want to use rollup. I mean, like React and Vue and all of them, there are libraries. And there are definitely advantages to doing this. And if you're writing a web app, you might want to use Webpack. This may or may not be true today, but of course there are advantages for libraries. For one, we support like all of the formats I listed before as output formats natively. So you can use this very same files, and yeah, you have 6 different ways to provide it to the users that they can use. And of course, as I showed you, the output is readable if your input is readable. And of course, annotations are preserved as well. And of course, you have the advantage there's no runtime loader overhead. Webpack will introduce the runtime loader. So if you write a library, then you get the runtime loader included once. Then you use the library in a project, so you get another runtime loader included in that project as well. So you've got 2 runtime loaders, like loadering around stuff. May not be the most efficient way to work. And we have a rich plugin ecosystem, so you can import CommonJS, of course. Without this, this would be kind of stupid. We have Babel support, of course, Uglify. You could even use Closure Compiler if you think Rollup could be improved. A Closure Compiler can do a few tricks that Rollup cannot do, but not many. We're working on this. You could even use TypeScript Elm and so on. It works in the browser, as you just saw. And something I really like, just by the idea, you can use a markdown document as source for your code. So basically, if every code block in your markdown document is a module, then this could be your module system. If you like documentation and like to write more documentation, this could be a way forward. So what about web applications? In fact, there are plugins for styles that enable you to work with Rollup as it was Webpack. So you import your CSS or less at the place where you use it. We have a dev server. It's not as cool as Webpack's dev server because we don't have hot module replacement, but apparently it doesn't work for most people anyway because it's really very special concept. And hot module replacement wouldn't work with Rollup anyway. And we even have a HTML template plugin, so something else from the Webpack world. And the cool new feature, and when I told this to people, said, okay, this is cool, why do I want this, is code splitting. How much time do I have left? A few minutes, okay. So just a very basic idea, because this is really worthy of its own presentation. So code splitting is the idea that when your application starts, you only need very minimal code in the browser to make it work, and then advanced functionality can be loaded at a later time. But the main problem with code splitting is if you have the same module as a dependency in both code blocks, so in the first code block and in the second code block, you cannot include it in both, or at least you cannot run it in both. Why? Because if the module has a variable in the module, then this is specific to this instance of the module. So if you run the module twice, there will be different variables. Those will not be connected. So how is this problem solved? Webpack solved this problem by including the module in the first and in the second chunk and check which chunks is loaded first and the other code is never run. So it basically ships a lot of dead code to your browser just to be safe. Rollup goes the other way around. We split the code in as large chunks as possible so that there's no duplication. Enough for a different talk, I guess. And yeah, there's this a topic where a lot of development is happening right now. So yeah, that's already all. Thank you for coming. So some thanks, of course, to Rich Harris, who said, oh, please do as you please. Then I didn't mention him, Guy Bedford. He joined us in December. Guy Bedford may be known to some people because he's the developer of his own module format called System.js and his own packaging system for this format. And he's working a lot more than I am working. Basically, we are now reviewing each other again. And got many other contributors, like there was Kelly Selden from Ember.js, which are working on including the code splitting part of Rollup into their setup. And due to their work, we now have a really interesting feature, which is in-place module rendering, which means you have your module structure, you run them through Rollup, you get an equivalent structure in the output format you choose, where every file is still at the same place, but unused code is removed. And yeah, and there is work also to integrate WebAssembly, of course. Everyone wants WebAssembly. Yes, and that's all. Thank you for coming.
Okay, thank you for your very nice talk. We have a lot of time for questions, so please feel free to ask.
First of all, thank you for the talk. You mentioned that you're not tracking like reassignments and stuff. So if you have something like let x equals empty object, and then the next line is x equals null, and in the next line you do like x.foo, which would throw an error, of course, at runtime. But this code is dead. Would you still remove it? So would you sort of like change the behavior by removing the error that would be thrown normally?
No, unfortunately not. So we would include all the assignments, basically. This is just the approach. So the first time a variable is reassigned, kind of its value is marked as unknown. And yeah, this is how we do it. We actually, I'm starting to read up on my IT skills right now, because I've studied, it's not physics, actually it's mathematics I studied, but it's never computer science. And the hope is that we can get something like a single static assignment form in there. So people who studied this may know what I'm talking about. This is basically changing variables so that each assignment basically creates a new variable, and each variable has only one value assigned. And if you do this, then you can really track the flow of the assignments, and then you can remove the unused assignments. But right now, the logic is a little stupid there. I kind of decided that, well, this provides very good performance already, and if you use a modern mutation-free coding style, then this really works for you. If you do not, if you have a lot of mutations, then you get a lot less optimal results.
Okay, so it actually works correctly right now because you wouldn't eliminate the error. So.
Yes, we would just keep everything.
Further questions?
My favorite question, how do you handle circular dependencies?
Yeah, this is a very good question. So there's two things. You mean circular dependencies between modules or circular dependencies between functions or something? Because the nice thing about the ECMAScript module format is, it just works the way it is. So one notion that people have is that if I have code where in line 1, no, that's a bad idea. If I have code that first defines a variable x, what is the other way? That defines a variable x in one function that is defined at the top, and then it uses the variable x in another place that is like before the other place. Then, okay, kind of bad explaining right now. So what I'm talking about is a definition is a temporal thing. So the variable x can be used from the moment it has been defined, no matter where the code using it actually lives. So by concatenating the modules, we do not change any of the semantics. So circular dependency are not a problem. They are only a problem if you're coming from a different module format, because they work different in Node.js. And this is one of the topics we are working on improving.
Yeah, thanks. So in your examples, it seemed like you have really advanced resolution of code. Does it mean you also run JavaScript while tree shaking, or does it? Because it sounded like you only look at the syntax tree, but I can't imagine how you can do all these optimizations then.
Yes.
Like for example, could you find out if I call a function of an object by using the string reference to the function of the object? It would be a dynamic reference.
I know what you mean. So you can access something via, for instance, a computed property. This is handled actually by a computed property is an unknown property, unless I can resolve it. So if I have bracket open, string x, bracket close, then we know this is actually x. And this will be resolved properly, but if there's really a computation happening that we don't know the result of, then we will say, okay, this is an unknown property. So whenever I call a property on this object, I will check, does this property exist? Does calling this property have an effect? Do unknown properties exist? Does calling any of the unknown properties have an effect? So this is how this is resolved right now. And similarly, if you assign a value via a computed property to an object, we just reassign all properties. seems like the simplest approach. So all properties are now unknown because we do not know.
So it destroys any optimization if I do a dynamic call to an object with computation in the brackets, basically.
Yes. Well, we try as hard as possible not to destroy, but yes, it will destroy optimization.
Other questions?
Thank you. You said that you showed that you are renaming variables in order to avoid clashes.
Mm-hmm.
Is there a reason why you're not using scope to avoid clashes instead?
You mean like wrapping everything in?
For example, wrapping it in a function call in
Yes.
a classic JavaScript, or using block scoped variables in ES6, I think. I don't know.
Yeah, that would be an easier approach, and that would work as well. But of course, then you would have all the function calls. It's more or less like this code is even faster and it looks cooler. But yes, this is the
So it's
reason.
an optimization thing.
It's an optimization thing.
Okay,
Yes.
because you're working hard to keep the code as it was,
But I'm
and when you're
renaming stuff.
renaming variables, you're not doing that. So it's kind of like a
Yes,
little
and
bit
there are some edge cases where people are not particularly happy. For instance, if you have a function, you can actually access its name via function.name. And this kind of can have unwanted side effects. So we're trying to actually keep the function name. So if I say constant x equals function y, then function y will remain function y. But if you say function y as a declaration, then we need to rename it, and then code, depending on accessing the function name, can break. The same goes for classes. Classes also do have a .name property that will be broken by these optimizations. So if this is really necessary, we might look into adding annotations or passing flags to avoid these optimizations, but it's really edge cases. Very few people really use these things.
I assume that the bundling using rollup takes. I mean, the question is, does it take significantly longer than Webpack, for example? Because I think you have to do much more inspections on the code itself.
Well, it depends if this is the first run or the second run. On the first run, rollup will be, I'd say, twice as fast as Webpack. The thing is, why it's not fast on the second run is because it's really hard to cache these things. Rollup Webpack has very good caching because, of course, since the modules are separate for most of the time in Webpack, they can just say, okay, these 3 need to be redone and these other 5 I can keep. So they really have to reparse these 3 modules. But Rollup could keep the AST parsing. We already do keep the AST parsing, but then the whole Rollup process itself needs to be repeated. Oh, okay. Oh, okay, my. Yeah.
When you pass through the code, in the example, you did one pass where you changed something, or you marked something, you did a second pass, you marked something, then you said you're done. But I guess you do a third pass and see nothing has changed, right? Because otherwise, how do you know that you're done?
Well, we used to do this, but then thinking about this, the only time ever anything changes is if a new declaration is added, or a new. So otherwise, there's no reason to include anything that hasn't been included before. We used to do this last pass, but I optimized it away and no one cried, so I guess it's not necessary.
So is there a reason to still use Webpack then? Or in other words, is there something that Webpack can do that Rollup can't do?
Well, they got a little more money put into them, I say, and a larger community. So this is, and they did nice work on this zero config startup you have in the latest Webpack version. So there are reasons to do this. My hope is that well, okay, this is the open source world, and I think we should all be nice buddies, and they do great work, and we try to do great work. But of course, my hope is that more people will use it, especially for smaller projects, because it's really nice setup, it's really fast, if performance is important to you. But then again, you'd say, okay, when React switched to Rollup, they made a talk about this and other improvements they did there, and they said, okay, switching to Rollup made our bundle 10% smaller and 10% faster. And you say, yes, 10% smaller, but this is 10%. You will probably only notice it if you like kind of have a stopwatch and sitting next to a computer and say, this is faster. Otherwise, I'd say it doesn't matter. Use whatever you understand best.
There's another question.
Are you like actively following the TC39, or maybe like the later stage proposal or something? Is there like anything in the future that gives you like headache already to think about how you would deal with that or something like that?
Actually, yes, there are a few things. It's more Guy Bedford who is in these processes, because, and I'm not sure, he's not a member of TC39, but he is a member of some of the Node.js processes. So what they are thinking about is to, there's a special property on imports, which is called import.meta. And via import.meta, you can today, for instance, access the URL of the file you are currently in. So this would be import.meta.url. So what the Node.js people are talking about, so this is not strictly TC39, but it's kind of related, is import.meta.require, so that you can call require from your ECMAScript modules. And this is really giving us headaches if we want to support this, because this will destroy the whole idea. Because require just works synchronously and destroys the execution order and so on and so on. Otherwise, we're trying to keep up with the TC39 process. So we can support ECMAScript 2018. This has been up for 2 months or so. And I don't see a feature that really gives us headaches. So our initial approach is, if there's a new feature, then using this feature as a side effect, and then we just optimize it so that it's only a side effect in certain situations.
Yes.
So regarding comparison between Webpack and Rollup, can Rollup also support dynamic imports?
We do support dynamic imports. And this is part of this code splitting thing. So this is probably the most obvious way to use code splitting. So if you use a dynamic import, so this is a dynamic import is basically is an import that looks like a require statement. You can use it anywhere as import, bracket open, file name, bracket close. And then it returns a promise, and then you can work with whatever is returned there. And we can use this to define code splitting split points, just the way Webpack actually allows you to do it as well. And so yes. And the nice thing, this gets even translated to CommonJS modules. So if you use an import, a dynamic import in your code, and export it as CommonJS, it will translate it as a require statement wrapped into a promise.
Okay, I see no more questions, and time is also up. So enjoy lunch, and thanks again.
Thank you.